Obviously, I'll start the class with a recording. Another class. On today's class, we'll be doing calculations for linear programming. Okay? We did the examples. And I would like to believe that we did attempt to do this, to use the software. The software can answer almost all the problems for this graphical method, and it will be able to answer the advanced methods in chapter 8, which are application methods. So for chapter 8, I don't know, I'll have to make sure that we do it online so that you can be able to be with your computer and then you'll be able to do what we do. Understand? Because it's 100% software chapter 8. So it means that chapter 8 is not part of our test because of it only uses the software. So this is where you have multiple constraints, not multiple constraints, multiple variables, more than 2 variables. You can get up to 4 or 5 variables. So yeah, it's quite intense. All right. So this is actually chapter 8. As you can see, the number of constraints, they are very long. And the variables also that we are measuring also are complex. Right. So let me just jump into our chapter 7. I will need a ruler. Where's my ruler? Okay, so now our first steps at problem 7.4. Okay, and it looks at problems. Guys, next time don't go too far. You must come a little bit close because of my projector is a cheap projector. It's not doing the things. I'm also struggling even if when I'm here, but I'll try. So now the Electrochem Corporation manufactures 2 electrical products. 2 electrical products. 1, air conditioners and large fans. Air conditioners and large fans. Product 1 and product 2. The assembly process for each is similar to that. It's similar in that both require a certain amount of wiring and drilling. So this is the activity that they must do. Wiring and drilling. Remember the example of a carpentry and paint and varnish. It's a lot similar to that. Wiring and drilling. Each air conditioner takes 3 hours of wiring. 3 hours of wiring and 2 hours of drilling. Each fan must go through 2 hours of wiring. Now the fan, remember I started with the air conditioner. Now the fan needs to go through 2 hours of wiring and 1 hour of drilling. During the next production period, 240 hours of wiring time are available. Ne? So these 240 hours of wiring time is available for both drilling and wiring. Ne? Sorry, okay, it's available for wiring strictly. Ne? And then 140 hours is available for drilling time, meaning for both the air conditioner and the fan. Ne? So you highlight again. Can you exceed the 140 hours? Okay. So ultimately you can see that you cannot exceed. Ne? So it needs to be less or equal to. Ne? So each air conditioner sold yields a profit of $25 or rand. Each fan assembled may be sold for 15 rand. So this one's for the air conditioner, and then for the fan. Formulate and solve this LP production mix situation to find the best combination of air conditioners and fans that yield the highest profit. So now you can start by differentiating the two products with a simple letter, such as maybe you say, for your own understanding of course, and to avoid any confusion, you can just say, this is too thick, let me make thinner. You can just say, for air conditioner, aircon, it's equals to X. Then fan is equals to Y. Right. Now we want to extract that information. We haven't yet started writing our objective function and stuff like that. You can go straight into it if you want to, but it's easier to start with extracting the information that you need. First of all, we know that there is X and there is Y. And also we understand that there is wiring, there is what you call wiring and drilling. So that I can just say W and drilling. Okay. Then it is stated that there is 3 hours of wiring and 2 hours of drilling. These are the times for air conditioning. Then for the fan now, we have 2 hours of wiring and 1 hour of drilling. Then we are given the time 240 for the wiring, 140 for the drilling. Then we're given the profits. Remember, I will not give you any test. They can go and make America great. And now we are in Mzansi. So now we have our objective function now it is very important to know the structure. Always refer to your book. I know Lena might cut corners there and there. You need to always refer to your book when you're not sure. Or put this in a software just to make sure that you understand what is required. The objective function now is so we are aiming to maximize what? Profit. There's something that keeps on disconnecting you. Let me rather do this. Apologies. Let me rather do this. Put away the mouse because it keeps on disconnecting me from my writing pad. So now equals to 25 rand plus 15 rand y, subject to satisfying these constraints, subject to meeting all the constraints. So this this objective function is subject to satisfying the following constraints. Okay, this doesn't want to move. Do this. Okay. Where's my pen now? Okay, there is 3. Okay, you can just still write your W to be safe. For wiring, W, like that, yeah. Then 3x plus 2y is less or equals to 240. This one is going to be 140. Let's drill 2x plus 1y. Even if when the one is not written, the one is it's always there. Again, even if it's not written, it's always there. Okay. Now, we want to find as part of our plotting of the graph, we want to find the points that intersect with our y-axis and or our x-axis. You start with that by finding the points that intersect your y and your x. This is going to be part of your feasible region. Ne? So you are first, and those constraints are part of the solution at the end of the day. When you look at the optimum solution, those regions tend to be part of the solution, or those points. Let me rather say those points tend to be part of the solution. So now, in order to find them, the ones that intersect with y will let x to become 0. Okay? For the wiring. So these are intersection points. We say x, rather, let x is equals to 0. Then it's going to be 0, that 3 multiplied by 0 to y equals to 240. You see that? So now this is gone. Again, we are left with these 2. Then, obviously, you divide both sides with 2, you'll be left with 240 over, and then what is my value? My value is 120. Okay. Then for x, you let y is equals to 0. Ne? And we're going to be left with x is equals to 240 over 3. Actually, you see now. Get there. We cannot always write everything. But in a test, you write everything. Because if you fumble, I have to find a way to give you something. Understand? I have to find a way to give you something. Which is part mark. Sometimes it's not even part of the memo, that mark that I give you. Because I now change and become a father in a way and say, hey, but this one had the potential of passing this and this makes sense. Then I start looking for ways to mark. But if you don't make a means for me to write, to mark something, we will mark together next year. 240 divided by 3, that is 8. Ne? Then, to be safe, rather you always write it in this bracket. Okay, this one is 2. Okay, then the ones that you find, you write them like this. X is 80 and then y is 0. Then x is 0, y is 1. What is 120? Okay. Then you need to find a way to draw them there nicely. So you have y as 120, there's my y there, 120, and then you have x as your 80, there's my x, which is 80. Then I flip it like this so that I can make a nice line. Okay. All right. Then we do the same. We do the same for the second formula, which is D. So let x is equals to 0. Then that one of 140. Do you see y is equals to 140? Do you see that? When x is 0, it's going to 2 multiplied by 0 is 0 plus 1y equals to 140. The other one is 0, y is equals to 140. Again? Right. So I need to write it here. 0, 140. The habit of writing your points will save you daily. The habit of writing these points will save you a lot. Let y is equals to 0, then x is equals to 140 divided by 2. Then that is your 70. 70 at 0. Then now 140 and 70. Okay, then I come and I do this. To be safe also, it's easy to forget which formula you used. You can label it and say this is for D, this is for W. Because once you are overwhelmed in a test, you no longer remember. We are all having anxieties, pressure, and so on and so on. So now the two formulas together, they intersect. Then because of we are dealing with what? We are dealing with maximize, then the sign here for maximize, our feasible region is this side. That's your feasible region. It's not yet your optimum solution. It's your feasible region. So it has points here, 1, 2, and 3, and 4. So there's a method that is called the corner method. What is it? Corner what? Corner method or cornerstone? Corner method. Corner method. Okay. So now we have A there at the top. A is already given. Okay? A is already given, which is this one. If you label it area 120, this one. A. That's your A. You see that? And then your B is the one that is unknown. Your C is also given, which is your C key number. Then you can just write them down somewhere here and say your feasible region. Feasible region. A, you bring them up. 0, 120. B, that is your unknown currently. Then C, it's known, 70 and a 0. So because it's too obvious, the two lines intersect, so we need to equate them. Understand? Because they are together. So in order for us to find this point, we're just going to equate them. Right? So now equation 1, which is 3x plus 2y minus 240. We have to bring the 240 this side because we are trying to equate them. Equals to, believing is 2x plus y minus 140. Then we'll start by solving for x. So in order to achieve solving for x, we bring all the x's in one side and then all the y's on the other side. Then when 2 comes this side, for argument's sake, it's going to be 3 minus 2x equals to 2. This 2y must go across, ne? So it's going to be y minus 2y. This one must also go across. It's going to be minus 140 plus 240. Then these two, you can see now it's going to be x. So our x is going to be these two. They're going to be negative y minus plus 240 is 100, isn't it? Okay. Then that's our x. That's our x. Then we solve one of the equations using that x. Understand? One of the equations, I'll choose this equation, this one here. You can choose any. You can choose any. Even as we are doing now, you can just select the other one if you want. So whenever you see x now, so you can just say let x for in formula in formula what in think this is drilling ne? All right, so it's going to be 2 open bracket negative y plus 100. All right, plus y minus, actually take 140 that side, just transpose 140. I will still get to transpose 140 again. We're not needing him, so he can go home. So now this is going to be negative 2y plus 200 plus y. Yeah? Then now you can see that we are left with negative y equals to 200 minus 140. Okay, let's transpose first. Let's make it jump the board. So this is equals to 140. Apologies for skipping some steps. Then negative 200 plus 140 is equals to negative 60. But we know there's a negative this side, there's a negative this side. When they divide, it becomes y is equals to 60. You see that? So now we come and place it here. We just said it now. This is 60. This one is... Oh, we haven't found the other one. We haven't found x. So we come and look for x on the second formula. Look for x on the second formula. How much space do I need when I write these things? Why am I chowing the entire page? Hey. Then now let y is equals to 60 on or in formula, I'll say w. So we're looking for x in formula w there. So it's going to be 3x plus 2 times 60 equals to 240. This is 120. 3x 240 minus 120. Then x is equals to 240 minus 120. How much is that? It's 120 still. All right. Then x 240. Okay, now we have 40 and 60. And I'm already at 60 there, although it's not perfect. You can see that, yeah, it's almost approaching 60. This side, it's approaching 40. So it's more like, depending how accurate. I agree with what paper we are required to be, it will give us a more accurate figure. Then now you take those points, the ish. Okay, I must do this. Take these points, paste them here, because we want to use the formula to find the profit. So I think no, I'm not happy there. Rather, I rather go away here. So now you need to say profit It's equals to I think it is 25 x plus 15 y, like this again. So whenever you see that, then obviously you must do this to make sure that you're not getting lost. So this one, you see, x is a 0 again. 250x plus 15120 equals to, leave it there. Then this one is a combination, 25 40 plus 15 60 equals to, then x is 70, 25 70 plus 15 0. Can I get my answers, please? 1.9. Right, the last one. Okay, then the optimum solution, now we say the optimum solution is this one, and it yields the highest profit. The optimum solution is that one because it yields the highest profit. It yields the highest profit. All right, so now we're gonna move right along. To a very interesting question. It says a candidate for mayor in small town has allocated 40,000 rand for last minute advertising in the days preceding the election. Net, the budget is 40,000 rand. Okay? The last minute advertising in the days preceding the election, two types of ads will be used, radio and television. Yeah? Two types of ads will be used, radio and television. $40,000, it's your budget. Can you exceed the must be within the budget. That's the first tip. You must be within the budget. Okay? So there are two types of the advertising methods. Radio and television. Okay? Each radio ad cost 200, ne? And it reaches an estimated 3,000 people. It reaches an estimated 3,000 people. What you desire is the reach, which is 3,000 people. Not how much you are being hosted. What you desire is the reach of people. And then each television ad costs 500. And reaches an estimate of 7,000. Okay, people, in planning the advertising campaign, the campaign manager like to reach as many people as possible, but she has stipulated that at least at least 10 ads for each type must be used. At least how many ads? For both, basically. Okay. Also, the number of radio ads must at least be greater than of television. The number of radio ads must be at least greater as the number of television ads. How many ads of each type should be used? Yeah? So this one, as I said, is a little bit tricky. So looking at the fact that we want to get more numbers, we desire more numbers of viewers. Therefore, we are saying that we are maximizing the numbers, basically. So the objective function is going to be we're going to maximize the audience, which is 3000 x plus plus 7000 y. So obviously you come back and say to yourself, TV is equals to y, radio is equals to your x, right? Then subject to, now we want to find our constraints. Subject to, we want to find our constraints. Okay, and then there is, you see, when they say they've allocated for both, you have allocated for both, that alone is x plus y, not greater than 40,000. That's your budget. It must never be greater than 40,000. So I'll come and rectify it. I suspect I might be wrong there. Then it is stated that your x will be at least a symbol is represented in this way, at least 10. Then your y should be at least 10 also. Then it stated that the number of radio ads must be at least greater as the number of television ads. So now it says X must be greater or equals to Y. And I might have always, I've been skipping one important constraint. It's always greater than 0. The non-negative constraint. Even this side, you must have it there. Where are your constraints? You must have it here. X, Y, greater or equals to 0. To show that we are on the positive of the Cartesian plane, something like that. I know mathematics sometimes it's not always our friend. So now this one, I am believing that I have to put the values here, the 240 here. I want to make an amendment here. I just forgot how I did it earlier. X plus 500 Y. Yeah, perfect. So now we need to draw our graph. I'll just draw it here on the side. Okay. Then in order for us to draw our graph, obviously we know that, okay, simple thing. Okay, let's start with the ones at the top there. We're going to say for the graph, let y is equals to 0, then y is equals to 0, then x is equals to 40,000 divided by 200 is equals to. Give me the answer, please. X is equals to 200. Then let x is equals to 0. Now we are looking for y. So y is equals to 40,000. Okay. And then over 500. What's your 80? All right, perfect. So we have 208. So remember I said even when I feel overwhelmed by this question, I must stick to the procedure. We said this is 0 because it's y, then 80, then 200, and then 0. Okay? And then the 10 and the 10, obviously. X, y is equals to 10, x is equals to 10. Okay? So now, before we go there, we look at your x. X must go out all the way to 200. Ne? So obviously it will require us to have a long line. So you can use maybe the 20. Ne? So 20, 40, 60, 80, 100, 120. 140, 160, 180, and 200. And now this is 82 fours. Okay, yeah. 2, 4, 6, 8. Okay, then that is 20, 40, 60, and 80. 20, 40, 60, 80, 100, 120, 140, 160, 180, 200. That's your point there. And another one at 80, that's your point there. Then let's come and write there. Okay, and then remember we're going down, okay? Then we're looking for 10. 10 is in between, again. 10 is in between. Look at that. There's a point here. What we are looking for, right? Then there's a point there that we are looking for. So now, and there is a point here, 10, 10. You see that? 10, 10. You have 10, 10. So those ones, maybe this is A, this is B, this is C. This is 10, 10. That one, it's X, 10. We don't know the Y. This one, it's X, it's Y. We don't know the X, 10. By one numbers, by judge. So the area here, agree these ones are going up. The greater or equals to. So that's your feasible region. That's your feasible region. Now, we're going to equate this. Whenever you see X, you put 10. And then on another case, whenever you see Y, you put 10. So there are two cases. For B, we'll start with for A, again. For point A there. We're going to say let X is equals to, let's just rather start with Y, is equals to 10. So now 200x plus 500 multiplied by 10, it's equals to 40k. I'll write it as 40k. Okay, I'm forgetting that this thing is infinite. Right, 40,000, like that. Okay, then equals to X. I see 5,000 minus 40,000 is 35,000. Yeah? 35,000 divided by 200 equals to how much? 175, like this, no points. Okay, number one. Then for B, obviously let X is equals to 200 multiplied by 10 plus plus 500 Y equals to 40,000. That is 2 grand. Again, 2 grand minus is 38,000 over 500, which is how much? 176. Oh, it's just 76. So this one is 175, just 175. Okay. Okay. Y. Okay, 175. See, and then 76. 76 comes here. Okay, they obviously approaching 180 this side, approaching 80 that side. 76 makes a lot of sense. Yeah. On a paper, graph paper, it will come almost accurate. So now we have our values. Then we have that guy there who says maximize. We gave him three sections, which is section A. Okay, so we sent to set views. Maximize what? Views again. Maximize. We call it views or what? No. Maximize audience. Audience. Hey, that a term that goes with English, guys. Hey, it runs out very fast, man. Hey, it's a problem. So the formula now, it's here. So for A, okay, the next up, homework, classwork. The next one, get classwork, you're going to shift this affair and this step. So, okay, 3,000 again for A cost 2. No. Yeah, 3,000. 3,000 multiplied by what? For A. 10 plus 7,000 multiplied by 76. You must get something of 500,000. How much, guys? 562. All right. Then the next one. Five 595. All right. Okay. I know that's your optimum solution, but let's do the last one. 520. 520. Which one yields the best, viewers? Second one. You see that? At 595. Ne? Okay. It yields more viewers. Ne? Then you take those coordinates. You need to also understand, will it still be under budget or within budget? Ne? You want to now see, again, you test the budget. Let's now test the budget. Youth, yes. So now it's going to be test budget. So if I were to ask you this in a test, I won't say prove which one yields the best. I'll try to break it down. Ne? Hey, but last semester now I was telling you guys, I didn't know stuff. So now I'm a little bit sober. Whenever I solve a problem, I ask myself, how can I pass my student in a systematic way that they just give me exactly what I want, and when I mark, I know point A, point B, point C, point D, So that's what I'll do for my test also. I'll ask you, is it within the budget? So now we're going to go to the formula for the budget, which is 200x, then we put the 175 plus, I think it's 500. 500. What is your y? Your y is 10. Get 10. Must be below 40k. Let's see. It's equals to 40k. Our optimum it's within the stipulated budget. The question was phrased in a very tricky way. For this one, I don't even have solutions for the book. I have to find smarter ways to derive the answers. And if you can't do the constraints, you can use the software. You understand? And there's a better way to do it. The way you always give the assignments. Where you copy and paste your assignments and give it to us. That's the way I got my solutions. So for every problem in this book, you copy it, you paste it on ChatGPT and say solve. Immediately already stated on itself which one is the best. It will give you the solution. Okay? But you need to analyze that solution as it makes sense. So basically, whenever you feel like I want to go and inquire, this one lecture didn't cover it in class. I don't need to cover it. AI can solve it for you. If you don't trust it, you send it to DeepSeek. And if you don't trust it, you must pray. Right, the next question. Get translate. Can't survive with translate. Never. I'm going to appoint people. I'll do the reading. Then I'll ask one random person for my objective function. After that, with the constraints, ka one, and then the graph, the solving, the whatever. This is a